Yeah. So today we are going to talk about the other new topic. Yesterday we had discussed about, not yesterday, I mean in last class, we had discussed about object class, and also we had gone little deep into the discussion of constructor calling mechanism and the MR method resolution order. And also we have gone and observed how the bytecode look like, all that. But I have also mentioned that if you think that is useful, you can use that, because what are the discussion we had done in the last class, it's a bit more advanced. So just think about it while using that, and we had covered all these things there. Okay, today session is also going to be useful one, and also we had discussed about object class in the last class. Fine. Now we are done with all this in the last class. So let's jump to the next topic in the OOP, object oriented programming. So the next topic is polymorphism. So we had already started with the OOP, and we come to know what is object, what is class. And also we have seen the memory level understanding of objects, how they look like, how they are created, what is heap, what is stack, the execution flow, methods inside stack, the principle involved in stack, last in, first out, all that. Then we had discussed about inheritance. Now we are going to talk about polymorphism, another core principle of OOP. So what is polymorphism here? Simple. One of the important feature of OOP is polymorphism. Poly is simple. I'll just quickly talk about this. See here. Okay. So what is polymorphism? It's poly means many. In general, this thing. Morphism means forms. Most of you should have this idea. Even then, just let us quickly discuss this. Morphism. Morphism means forms. Morphing means forms, right? You keep hearing this word morphing. So polymorphism means representing same method in different forms. And that is what we call polymorphism. So same method we represent in different forms, or we implement in different forms. Okay. So that is what we call polymorphism in different forms, and we call this as polymorphism. And one important thing about polymorphism in Python, generally we know we have two types of polymorphism, compile time and second one is runtime. Okay, in compile time, again, this is implemented with two things. One is method overloading. Okay, the other one is uh, operator overloading. Operator overloading. These are two types of polymorphism. And this method overloading, this is not directly supported in Python. We don't need this actually. Why? Because we'll talk about that. So this is not directly supported, but indirectly supported with default arguments or that variable length arguments. Using such arguments, we can implement method overloading. Like in Java, like in C++, like in C Sharp, we don't have a concept of a direct method overloading in Python. But still, we are not missing on anything. If you ask a question, in such case, do we miss out on anything? So the answer is no. We don't miss on anything. Everything is in place. Still, we can achieve that overloading with whatever we have in Python, right? So that is important point to observe. Compile time means that method binding happening at the time of compiling a program. So that is compile time polymorphism. Here we implement that with the overloading, and that is not directly supported in Python, but we can implement it either with implement with either with default arguments or with the variable length arguments, either with using default args or variable length args. Okay, variable length arguments. Hope this should be very clear for all of you friends. Okay, this is fine. Just remember, we'll talk about it with a practical example. Operator overloading. Yes, operator overloading is supported in Python using magic methods. What is that magic methods? Magic methods like underscore underscore add. Okay, something like this. Or underscore underscore mul, something like this. Using such magic methods, this operator overloading is supported. We'll see one or two examples that should give you a clear idea. But we are already familiar with that. We can do this overloading right without magic methods or with magic methods. We can do it in any way because now you are clear with that object and class. You can play with those things in whichever way we want. So that is the idea, right? So got it right, friends. So this is about compile time, right? So what is compile time means simple, right? We method binding happens at the time of compiling a program, and that is implemented with method overriding and operator overloading. Sorry, I think method overloading and operator overloading. Method overloading, we should be very clear. It's not directly supported in Python. However, we can achieve that with default arguments or variable length arguments. Operator overloading, we can achieve that by using this magic methods or dunder methods. People call these methods also as dunder, D-U-N-D-E-R, dunder methods. And runtime polymorphism. Runtime polymorphism is nothing but this is something which where method binding happens at the time of executing a program. And we achieve this with method overriding, very useful scenario. Already we did this. If you remember, we did this overriding with what friends? With constructor overriding. We did this in last class. But still, this session should give you a very detailed analysis about method overriding as well. So this is runtime polymorphism. Okay, method overriding. We'll talk about all this in detail in today's session. Definitely, this session gives you a in-depth idea about everything what we are listing here. Okay, so how do we achieve runtime polymorphism? We achieve that by using method overriding. Maybe if you are asking questions like, what is that? Then we are going to have a detailed discussion. We'll talk about that. So these are all different types of polymorphism we have. Method overloading, which is, oh, sorry, method overriding, which is part of runtime polymorphism. Method overloading, not natively supported in Python. Next, after that is operator overloading. So if it is operator overloading, generally that is compile time part of compile time polymorphism. Even method overloading is also part of compile time polymorphism, as we discussed just few minutes back. And duck typing, we'll talk about it. It is part of dynamic polymorphism. So we'll see all this. These are all different types of polymorphism. So we talk about overriding, overloading as well, even though it is not natively supported, but we will understand how that overloading is implemented in Python. Operator overloading, we'll see how we do that. And duck typing, this also we'll see how we do that. Okay, next one. Let's come to the topic of method overriding. What is method overriding? Just understand definition. If you have a clear idea about definition, right? If you have a clear idea about method overriding definition, then this should give us a clear picture. What is that? Method overriding or runtime polymorphism is simple. A child class override method of its parent class to provide a specific implementation. Okay, so we will see that with example. Let me just open PyCharm. I just restarted my system today. Let me open PyCharm. Meanwhile, we can just discuss this until that PyCharm is open. See, this is simple, right? You have a parent and you have a method in that, which is nothing but sound, right? And parent is animal. Now you have implemented something in that parent. You can see this. Print animal make different sounds. Now I want to define same method of parent in subclass, but with a different implementation, right? So what is that we should do? If we should override method of parent in child, first a relation must exist between these two classes. That is inheritance, you can see. We inherit a parent class to a child class. You can see this. Our parent is animal and child is dog here. And we are inheriting animal to dog. And then we are overriding sound method. Right? This happens not only sound, and we can see this kind of implementation with different scenarios. Okay. Here, what is child is doing? Here, this child class override a method of its parent. This is the method of parent. We are overriding in subclass, defining same method in subclass with a different implementation. Logic changes. It won't be the same logic. If you are using same logic, then there is no need for overriding. That's not needed. So that is the simple idea. We will now I'll show you here quickly. Okay. Let me show you that here. I'm closing this. Let me open this, right click. Just a minute. It's taking a bit of time. It's okay. Meanwhile, we can, yeah, super. I'll just explain that with example. You feel it's so simple for overriding because it is one of the very easiest topic in Python, not just Python, in OOP to understand overriding. So we can say poly, we can give the name as polymorphism, and maybe you can say overriding. Okay. Now you can start doing the code. You can take a class. You can take a simple example. We'll talk about animal and dog later. I'll just make you understand it in a very simple way with a small example. You take class FMA and define a method M1. Okay. Assume that you are just saying something like print M1 here. This is simple, right? Is there any difficulty in this? We don't have any difficulty. We just have a class and just one method inside that. Now I take another subclass, class B, inherit that from A class. So what is the requirement? I want to change the implementation of this parent in child. I have a different functionality to implement for this method. Method name should be same. Signature of method must be same. But what should change? The internal logic of this method should change. How do we override that logic? By inheriting this class into a subclass. And you take this method now, implement it in subclass, right? And change the implementation. This time, instead of M1, I say that, so some B here. Earlier, do one thing, make a small change, put print A. Now this is overriding. We are done. Simple. So overriding means simple. You have a method in a parent class. That same method we implement in subclass. The signature will be same. Rule is signature have to be same. but implementation changes. Inside method of parent, we are saying print A, but inside method of subclass, we are saying print B. What is the difference here? The logic changes. Of course, we are just printing here for quick understanding. But in a real time, if this kind of scenarios are required, when you want to override the logic of method of parent in a child class. Right? Things keep on changing. So to adapt to those changes, this kind of extended functionality is implemented by overriding such methods of parent in subclasses and implementing a new functionality in the subclass methods. That's all. Now what do you do? Just create object for subclass. You don't need to create it for parent. If you want, you can create for parent. That's up to you. Now what do? You just say M1. Now which method is called? Is it the method of subclass or method of parent? Definitely it would be method of a subclass. When I run this, you get output from subclass method. So this is simple and quick idea about overriding. We are done. Overriding is a simple mechanism where you define method of parent in a child class with a different implementation. That's all. It is this concept of overriding. Generally, in this kind of polymorphism, this is the method you are calling, right? When you call M1, you have two copies of M1, one M1 in B class, one M1 in A class. Which M1 is called here? This binding of method to that call is nothing but when this is happening. Is it happening at runtime or is it happening at compile time? Is what we call runtime polymorphism or compile time polymorphism. Generally, in runtime polymorphism, method binding happens based on object. Based on what, friends? A method binding happens based on object. If the object here is parent, then the method of parent is called. If the object here is child, then the method of child is called. That's all. Very simple MRO, method resolution order. Very simple MRO here. So this is what we should remember, friends. Okay, so that is the idea of overriding runtime polymorphism. Okay, I'm copying this and sharing this simple program with you. Let me share this code with you. It is a very simple example to quickly understand. Let me share this. Yeah. Next, after that, once this is done, we'll take another example to understand little more this thing into that. Suppose one more example. Maybe you try to understand this more. So animal override. I just take example of animal here. See, I take class animal. Okay. I just define a method sound as just we have seen some time back. And just, different animals make different sounds, right? So we can say print. For now, I am just defining animal make different sounds. Okay, this is the parent implementation. These are all very interesting scenarios, interesting topics, friends. Okay, now I want to define this in subclass. How? Class dog, inherit animal, override, animal is generic one. Dog has a different sound, cat has a different sound, right? Similarly, lion has different sound, tiger has different sounds. Suppose if it is dog, so if I am defining sound method, the sound of dog is something like this. What is that? Something like some oof. of, right, rough or something. Okay. Means what? In the super class, you just implemented it saying animal makes different sounds. But in the subclass, it is animal is very specific. Super class is something animal common for all animals. But dog is specific. So we have to override sound according to dog here. See. So we changed that implementation. Instead of animal makes sound, we made it as oof oof, something like how dog makes some sound. Got it right. Similarly, you can take another example, cat. So cat has a different sound again and inherit that cat from animal itself, which is this kind of inheritance is hierarchical. We had discussed this. Same parent, many childs. And this time, what is the sound of cat? Uh, Sound cats meows. So we say meow meow something like this. Okay. And for a dog, we just say some oof oof. This example should give us a very clear idea. Now this makes more sense, right? When you have three different classes, one parent and two childs, the sound in animal doesn't suit to sound method in subclasses. So what do we do in such case? We override method of parent in subclasses according to subclass requirement. Simple, right? This is a clear and simple scenario of overriding. Now, finally, what do? If you want, you can create object for animal, object for a animal, and D dog. Okay, and then C cat. Now, finally, you have to call A dot sound and B dot sound, not yeah, D dot sound, and similarly C dot sound. By looking at these methods, which method is called on A, which is called on D, which is called on C, we can easily understand by looking at these objects, right? When you say C dot sound, whose object is this? This is cat object, then the method from cat class is called sound method from cat class. Simple. Runtime polymorphism occurs based on object. Simple. Got it right? So this is the idea. Let's run this now. So just remember this point. What is that? Runtime polymorphism. Very useful point for you. Morphism occurs based on object. Okay. Just remember this. Right. So finally, what do? We implemented this overriding with much more little bigger example. So finally run this. What happens now? You can see the output. We are trying to call all three methods from three classes through their objects. Right? We have meow meow, and then we have woof woof, and then animal makes different sounds. So this is the idea of overriding, friends. Got it right? If you are not satisfied with method of parent in child override that method with a different implementation. That is what we call overriding. This happens even in real life as well. Okay, what happens? This happens even in real life. Suppose parent makes some decision, child might override with some other decision, right? So there are so many scenarios like that. Okay, so this is the idea. Let me share this code with you as well. So I'm sharing this. So you can take this now. So done with overriding. Let's next example. Method overloading. We'll try to quickly try this. So what is method overloading? We'll try with asterisk arcs this thing so that gives you an idea. See why we don't have overloading method overloading is supported directly, or it's not that much supported in Python, like in C++ or Java or C Sharp. Simple. One simple reason. Let's take that example to make you clear and clearly understand. Method overloading. See, you define a method, friends. Any method, define some add, take two parameters A, B. See, one thing in Python is Python variables are dynamically typed. What is dynamically typed? We don't need to define data type in Python. By looking at data, implicitly interpreter itself declares that data type. It assigns data type. This is what happens in Python. Now you say AB, we don't know what is this AB. Is it an int type, or is it a string type? Is it a float type? Is it a class type or object type? We don't know what is the type here. Suppose you say here, friends, very simple, print A plus, or you can directly say return A plus B. See, when you say this, you are saying print add of 1 comma 2. This time, now this is, we are calling add by passing what parameters? Int parameters or int values. Suppose you do one thing, you take another example. You can pass some 20.0 and 30.0. This is decimal type or float type. Next, third one. We passed integer parameters. We passed float parameters. I'm trying to pass third thing. Third thing is I am just passing here. What is that? So some A, some B. I'm passing string parameters, string values otherwise. Okay. When I pass string here, of course, we can also add string values or string variables. Nothing happens. Adding strings is called concatenation. Now you see this example should depict a clear picture of overloading. If it is C++ or Java, they define two more copies of add because they are static data types. We have to mention data type. We should define add method for integer parameters, add method for float parameters, add method for string parameters. I'll just show you here how it look like. But for Python, you don't need that. This one method serves all that. Now, if you run this program works. See, we are calling add in three different forms. But first time we are calling by passing integer parameters, and second time by passing float parameters, third time by passing string parameters. You can run this now, just run it, just change. Okay, I will see it. It is throwing. You can see all three use cases are working for us. First time we got 1 plus 2, 3. Second time we got 20 plus 30, 50. Third time even string concatenation is happening. And we are achieving overloading in Python. That is already there. It's not like we don't have overloading. It's there. When we say not natively supported in sense, it's not like we don't have overloading, but it is implicitly available in Python. When it is already there is no point of again explicitly implementing that. You got it right, friends. So this is the idea. Overloading is there implicitly in Python. Same thing, suppose if it is Java, C++ or C Sharp. In Java, you have to define like this. If they say something like, I'll just show you a small example, okay? How Java people define overloading. See, something like this. They say something. They have to have everything should be inside a class in Java. Suppose you say class test, okay? Opening brace. This is how Java code will be. And you can say void add of, this is how they define. This is, we are overloading add method. And they say int a comma int b. This is how they work in Python, and they say return a plus b. Most of the code you can easily understand, except here and there few things. So we have just defined a method for passing int parameters. Now I need two more methods. What they do in Java, they try to define one more method with the float parameters or double parameters. You can define double here and here also double. And after that, you define a string here and a string here. Okay. So that's all. This is how we overload methods in other languages like C++ or like Java or C Sharp. You can see add is declared with int parameters. You don't need to understand anything here. I'm only just giving you a little idea. Add is implemented with double parameters. Add is implemented with string parameters. And this is overloading. Same method with different forms. What is changing here? Data type is changing. Parameter list number of either data type should change or number of parameters should change. You got it right. Suppose if you are using all two integer parameters, then in this method, instead of two, you should take three. That is the rule of overloading in Java or C++ or C Sharp. Got it right. This we have already there in place in Python. Just want to show you. We have already this in place. Then why again we worry for overloading? Already method is there. Just pass whatever you want to the same method because our parameters are dynamically typed. So we don't need three add methods here. We don't need to overload add for three times. Just one method is enough to take care of all different type of parameters. Right? So that is the idea, friends. So overloading is in place. We can pass whichever parameters we want and we can test that method. That's all, friends. This is idea about overloading. Let me share this example with you. Next, after that, once overloading is done, next topic is maybe you can try one more quick example. You can take variable length argument. Suppose you take star args here, right? And you can say return. How do you add this? You can pass one parameter, two parameters, three parameters like that. In this case, what is that? You can simply do one thing. You need a little bit of to do sum. The easiest way is return sum of args. This should work because args is a tuple. We can directly call this sum on this add method. Sorry, on args parameter. It will try to add all that values in the tuple and return that. That's all. That is the easiest thing to test that. Okay, so what do you do right now? Now you can call args with two parameters. Args with suppose you see here add of 1 comma 2 comma 3. Now okay, add of you can just test with two parameters, three parameters, four parameters. If you want, you can try with four also 1, 2, 3, 4. Likewise, you can test with how many scenarios you want. You can pass float values, you can pass string values, and you can test all that. Now run this now. Now you can see that the outputs 1 plus 2 is 3, 1, 2, 3 is 6, 1, 2, 3, 4 is 10. Likewise, you can test, you can pass different parameters to this method and you can do whatever logic you want to implement. And finally, you can accomplish your required this thing there. Got it right, friends? So this is the idea of another example of overloading. This is also an example of overloaded method. One method is able to implement or is able to take different size of parameters. which is nothing but one of this thing of overloading. One of the use of overloading. One method should be able to, we can test one method with different size of parameters or different type of parameters. So we can do both with this method, whatever we are defining here. Okay, let me share this code with you. You can also use this for testing purpose. So what is the rule here? Either with overloading, what we can achieve is simple, friends, simple scenario. We should be able to, we should be able to test with the different size of values. Either number of parameters should change or type of parameter should change. Simple. I just make it simple here. Either number of parameters should change or type of parameters should change. Can we do that here? Definitely. You can see number of, in this case, number of parameters are changing. In the first case, we are passing 2. In the second case, we are passing 3. In this third case, we are passing 4. In the fourth case, if you want, you can test with float parameters. Why don't you test with float here? Just instead of it, you say something like 10.0 and 20.0. Just test like this. This should be fine. Now run this. This still works, right? See? And we are achieving that overloading principle there. See, whenever we talk about overloading, the important thing is either number of parameters should change. So purpose of overloading is that you want to test your method with the by changing the size of those parameters or by changing the type of parameters. And we are achieving that here without implementing multiple methods here. We don't need that here. One method can do all that. That is what happens in Python. And finally, the point conclusion is we have polymorphism in place. We don't need to say that overloading is method overloading is not supported. Method overloading is already in place in Python, simply speaking. Got it right, friends? I'm just sharing this also with you. You can test it. But the difference is we don't need to overload methods in Python like in Java, like in C++, like in C# or any other traditional languages, because we have, as our parameters are dynamically typed, one parameter can accept different type of value. We don't need to worry about that. So finally, this is the idea, friends. Got it right? So next after that, let's jump to the next example. We are done with overloading. We are done with overriding. Next example is this is operator overloading. And this is interesting example. You can try with any example. It's need not to be point here. To do operator overloading, what do we do? What is operator overloading? So operator apply, generally we don't apply operator overloading for primitive types. Suppose you see here, applying plus on objects here. You see here, this is one object, this is another object. And you apply plus on objects. That is where operator overloading comes into the picture. Just to apply plus on primitives, we don't need overloading, operator overloading. So when this operator overloading is needed, if you want to do some addition on two objects or one object. So there are so many scenarios like unary operator overloading, binary operator overloading, right? Two types of overloading. Unary means you do that overloading of operator on one object. That is unary. Binary means you apply on two objects, something like this. And such kind of overloading is nothing but operator overloading. So just to say that, see, simple example, let me close this, take something like this. Operator, let us take a simple example. We'll close all this today. I don't want to carry forward for tomorrow. Let's try to close this. What is it here? Simple. See, when you say print of 1 plus 2 or this is, we are applying plus on two operands. We call this as binary operators. Also, suppose now you see here, you say one more example, -1. We are applying -1 on single operand, unary operator. We are applying this on unary operator on some operand. If you apply one operator on an operand, this is unary. We are applying unary operation here. Okay, let's run this now. You get output as 3n minus 1. If you apply an operator on one operand, that scenario generally we call it as unary operator overloading. Okay, operator overloading. And same thing if you apply on two operands, it's binary operator overloading. Okay, this should give you a clear idea. But when this is called unary operator overloading or binary operator overloading, generally while applying on primitives means like on int or float or all these types, right? On data types, not like class types, but on these types, we generally, this is not overloading. When overloading is needed is when these are objects. Suppose you have a class, like just we see an example of, if not point, you can take anything. You can take a as well. In that A, there is a constructor. You can take a constructor int and you define two parameters, self.xi. If you want, you can read it from keyboard or pass it something like that. Okay, self.x comma y. Okay, you can try like this, x comma y, self.x equal to x. And one more example is, I'll just show you here, self.y equal to y. You got it right, friends. So over, we are done with that. Now next, what do you do? This is the simple very simple example to understand operator overloading. Operator overloading is nothing but we apply operator on objects. What is that? We apply operator on objects. To achieve that, so applying operator on primitives is something we do regularly. That happens always. But what is this here? This is a special case where we apply operator on objects. For example, let us understand this with this example. Right? This is needed, friends. Whatever I am discussing here, this is something useful to you. Sometimes these are needed for interviews. These are needed for this certification exams. Sometimes these are needed in your development as well. Right? These scenarios are needed. Right. Finally, what do you do? Create two objects, some a equal to a or something like a1 equal to, pass two values, 1, 2. This object has 1, 2. Again, create one more. Okay, a2, and then you can say something like 3, 4. Now I want to apply addition on two objects, something like a3 equal to a1 plus a2. See this. This is something really interesting. What we are doing here, we are trying to add objects. If I should add objects, before that, what is needed? Operator overloading should be in place. What should be in place? An operator overloading should be in place. Got it right? If I directly do this, right, this won't work. This won't work, friends. Okay, suppose you try to print off A3. Let's see this if this works for us. Right click, run this now. Let's run this now. Print A3 here. Okay. Now you got an error here. See, type error saying that there is some kind of unsupported operation here because we are calling plus on two objects. If it is plus on primitive data or some numeric data or something like right where we can apply plus, it is okay. But this plus is not cannot be applied on objects. We cannot add two objects just like that. We need that overloading method in place. And if that should be in place, what is that we should do? We can achieve that in Python by using what? By using magic methods. What methods? We can use that magic method here. You can take this, right? Simple. It's a very simple thing. Okay. So you can add a magic method and just take one additional parameter. Self represents a current class object and other represent another object. No problem. So here the logic is simple. Return in, you can simply say, what is that you can say here? You can simply say self dot x plus other dot x. There are two objects. One is in self. You are passing when you say a plus a1 plus a2. By default, a1 should be passed to self, a2 should be passed to other. Now you have to add x from this both objects. So one from a1, 3 from a2. So how do you add it? Self dot x plus other dot x will add this x from both objects. Okay, comma again self dot y plus other dot y. Sorry, friends. So this will add y from both objects 2 plus 4. So this is doing 2 plus 4. This is doing 1 plus 3. So this is how we can add objects in Python, and this add method, magic method, helping us to overload plus operator. What operator? This plus operator. This is binary operator overloading. We are adding plus on two operands between two operands. So this is binary. And here we are trying to see a1 plus a2. This time definitely this will work. We don't have big issue here. Right? Only thing, yeah. So finally you can print A3. Run this now. Let's see. See this time, happily this is working. You can remove this for now. You can comment this. This is not needed. That is only just for understanding. Now you see this. Now run this. See how simple. 1 plus 3, 4. 2 plus 4, 6. Perfect answer, right? See. Is it adding these two objects a1 plus a2? When I do this, these two objects are added, and that x of this both objects is nothing but when they are added, we get 4 here. 1 plus 3 is 4 and 2 plus 4 is 6. This is clear, right? So this is the concept of overloading in Python, operator overload. This is how we overload operators in Python on objects. Is this clear, friends? This is simple and clear example. Here only thing is we override this magic methods here to achieve that operator overloading. If it is C++ or Java, they have some dedicated methods. Like C++ uses that plus itself as for overloading. Some kind of syntax is there, they follow that. But Python achieve that just by, what is that? By overriding this magic method. Simply, you can achieve like this. Still, if you want to know little more, we can put a debugger and see how that values are passing. Simply, you can do one thing. Put a debugger here, right click, debug this. Right? Just a minute. Yeah, we are here now. When you say this is actually going to call add method implicitly. So what do you have to do? At this stage, at this line 14, you have to say step into. When you say step into, observe this here. See, self is holding a object and okay, this other again, of course, but the objects are different here. Both are a objects, but see here. So for first inside self, the address of one object is different, and inside other, the address of other object is different. You can see this. If you want to know much deeper, do one thing, just print object of A1. Just directly print reference of A1. If you want to see that which object is passing to which parameter, print A1 and A2. And you clearly understand to which parameter A1 is passed. Is it to self or other? And which parameter A2 is passed? Is it to self or other? That gives you a clear idea. Okay. Now you can do one thing. Again, you can debug this, restart the debugger. This should give you a clear picture. Okay. Now we are at what? At line 16. And now A1 is at 100 at the end and A2 is at 130. Now just say step into. And this should now it's a clear, we have a very clear differentiation. So what is A1 here? Already we know just some time back 100 is A1 and 130 is A2. So that A1 is passed to self and the A2 is passed to other. Using these two, we try to add that two objects or values inside those objects and just we return that. And finally, an addition on two objects happens with this dunder method. So that is the idea. Now, if you want, you can say step over and finally it adds those two objects. And finally, when you say step over, it prints that we get that output. So this is the idea, friends. This is idea of operator overloading in Python. Finally, we are able to understand polymorphism. What is that? One is method overloading or compile time polymorphism. In that we had now clearly discussed method overloading, operator overloading. And then in runtime polymorphism, we have already clearly discussed method overriding, how that, what is the need for overriding, how to override a method, right? And then how to test it, all that scenarios. Now I am sharing this as well with you. Operator overloading example. Let me share this with you. Is this clear for all of you, friends? Next one. So this is about operator overloading. We are done with this. Okay, next one is let's talk about duck typing. This is a very simple example. For duck typing, you can take the same example of animal. We use animal and sound, right? I'll just make you understand it very simple. But just understand that what is duck typing, right? Or dynamic polymorphism. Well, I'll just give an example. So that should give you a much more better understanding here. Okay, so let's do that. Here, polymorphism, animal override. Okay, let's take this. I'll take one method, a common method, def. Okay, I'll just name a method. You can remove all this if you want, or you can keep that. That is fine. Okay, get sound, and you take that something like animal. That animal can be any animal. Okay, then you say animal dot sound. This is fine. Now I have a question for you, friends. What is dynamic polymorphism means? You can see this method. This is a very generic method where you have a parameter animal and you are calling sound, right? Now the question is what, friends? Which sound is called here? Which sound is called? Is it sound of animal itself or sound of dog, sound of cat? Everything is an animal here. Which animal is called here in this sound method? How do you know? Again, that you understand through objects. Through what? Through objects. Let me show you how duck typing is very simple, friends. See, remove all this. You don't need all this. Again, this point comes into the picture. This is runtime polymorphism, right? So to understand this with a very simple thing, runtime polymorphism or dynamic polymorphism occurs based on object. Right? So what you do here, you say get sound of animal. You pass that object. Now you can say in this get sound, the sound method of animal class is called. But if you don't have this color and if you don't see this object, then you cannot say which sound is called on this method. On this method, right? This process, this is called duck typing or dynamic polymorphism, where until you pass that object, you don't know which method is called. And I clearly mentioned runtime polymorphism occurs based on object. Whose object is here we are passing animal class, which is nothing but parent. So that the sound method of parent is called here. Suppose you do one thing, another two examples. Okay, get sound of animal is fine. Now you do one thing called dog. And similarly do one thing called cat. Okay. Now which methods will be called? So which sound is called? By looking at dog, you can easily identify now. Sound method of dog is called. By looking at cat, you can easily identify sound method of cat is called. Got it right, friends? So this is what we call duck typing in Python. Not only Python, in Java or any language. Got it right, friends? Now run this. So you can see we get that animal makes different sounds. Something like second time this is coming from sound is coming from oof. You can see that, and sound is coming from meow. This approach, right, is what we call duck typing. Right, we are dynamically in a trying to call sound method. Right, until we pass that object, we don't know which sound to be called. And this approach we call duck typing. Let me share this example also with you. This example is for duck typing. You can just have add that on top of each example. Okay, duck typing. So copy this and let me share this with you. Okay, insert this, pass it here. So this is overall idea about what polymorphism, friends. We try to cover as much as possible. So this is dynamic art duck typing and same example, but here this guy took bird, but we took that animal as example. So to implement example or scenario, right? We can use whatever we can choose, whichever I think fits into the use case. So finally, this is all about polymorphism, friends. We try to cover as much as possible. Yeah, friends, sorry, there was a slight network glitch. I think we are done for this today. Yeah, friends, thank you. Yeah, we'll stop here. We'll come up with another important topic tomorrow, that is abstraction. Okay. Any more questions? No questions, right?